Kevin Anderson from Manchester. I noticed you in engineering, which is interesting.
Yeah, I'm originally an engineer.
Oh yeah, okay. So Kevin is well known to many people. He's previously director of the Tyndall Centre for Climate Change Research, now co-director. Normally when you say a fellow scientist that they're brave, you don't mean good things. But in Kevin's case I do. Kevin has been very vocal and engaged with policy at all levels and extremely courageous in what he said and to who. So for that, I applaud you. And look forward to hearing what you say. He's always provocative and interesting, so please stay awake.
Thanks very much. I'll start off with an apology. Always a good thing to start off with the presentation. I've been doing some additional work, particularly related to cement, which is all very exciting stuff. And I had hoped to put that work in today. In fact, I put it in somewhere in last night, and it corrupted. And so when I opened up the train this morning, it didn't work. So I've had to go to a slightly older presentation, so it's not quite as up to date as I hoped it would be. But it's still, the numbers are all broadly the same. Nothing significant has changed yet. Well, I'm going to start off with what I've just called here Chatham House quiz. I'm taking you all know quite a lot about climate change. Some of the faces I recognise, so I know some of you know a lot about climate change. You all know something about climate change. You all know something about the Paris negotiations end of the year. You're all familiar with climate change issues. Great, that's fine. I wasn't too sure. Well, I just want to ask you some questions here, and I'm not going to take any notes of who says what. If Paris delivers a genuine global commitment, right, so we have something worthwhile, well, we have something genuine coming out of Paris. Who here thinks it's realistic to reduce emissions in line with a likely chance of staying below 2 degrees C, what we sign up to every single year and have done since the Copenhagen Accord? Does anyone here who works on climate change think 2 degrees C is still a viable goal? Right, beg your pardon. I'll put my hand up. I'm the only one, and I spoke to the Met Office recently, it was just 2.
I'm going to go with it. Yeah.
Good.
It'll lead carbon dioxide removal, Kevin.
Oh, but this is emissions reduction, right?
This is emissions reduction.
Oh,
well, right, so we might come back to that.
His hands go
Yeah, right.
There must be other people that
Right, but that is really common. Everywhere I go, you get that same response. You get the same response from Stern and all of the great and the good when you suck some claret with them or a bottle of beer or something. They'll always say that away from the microphone. No one out there I've come across yet who says it's 2 degrees C is viable, except for when there's a microphone in front of them, they'll say it is. And all their reports will say the same sort of nonsense as well. I think it is viable.
Were there any hands up in Cornwall, by the way?
Anyone there think 2 degrees C is viable? This is so depressing. What's the earliest date? The non-Annex 1 countries, I think that's probably the nomenclature you're all familiar with, the poorer parts of the world. It does include China in there as well, so the non-OECD countries effectively. And what's the earliest date you think they could possibly peak their emissions?
To avoid 2 degrees?
Well, no, just do you think that if they were pushed, if they were pushed, that's a very colonial way of viewing it. If they chose to go along the lines of doing something significant on climate change, how early do you think they could peak their emissions collectively, the poorer parts of the world?
2020.
You think they could peak by 2020?
Because it's all China, right?
Okay.
Yeah.
That's the most optimistic answer I've ever heard.
Are you talking politically or engineering-wise?
In practice. But
in practice,
imagine there's a genuine commitment. They wanted to do it. When do you think they could peak their emissions?
2040.
Okay.
2050.
All right. So Peter's response is very unusual, and I've not met any Chinese people say that as well. 2025 is when from the work I've done with Chinese colleagues and so forth, is about as early as I think it's viable. 2020 I'm amazed by.
They committed to 2030, didn't they?
They committed to 2030, yeah.
So they must be able to do it.
But remember, then there's India, who's got 1.3 billion by 2020, probably.
That's true. All right.
Yeah. But what's interesting about it,
then.
the Committee on Climate Change recommendations to the government are premised on China peaking by 2017, the rest of the world by 2018. If you peel away all the bits of the outside of the onion, you'll find in the middle these things that are completely unsupported by anyone's views or sets of assumptions that you would explicitly make. So the policies in the UK on climate change are premised on India peaking by about 2017-ish, that's right, India and China, and the rest of the world by about 2018, and globally peaking in 2016, though they're redoing that stuff with a sort of slightly later peaking date now. But that has been true for years, and look at virtually all of the papers out there that inform governments, virtually all of the integrated assessment model outputs, and they virtually always peaked emissions between 2010 and 2016. A lot of the papers include one by Nordhaus and one by Hansen, there were both policy-related papers, peaked emissions in the past. Now, unless you believe in going slightly, Einstein got it wrong, then that's not possible. Yet those papers were put out there as guides to policies with the peak in emissions in the past. Virtually all integrated assessment models fiddle their data on it, or fiddle their outputs on this. So, when do you think global peak could be? When do you think you get a global peak? Any thoughts?
2025.
UK policy is proposed on 2016. And that's pretty much the same for all of the work that's out there, that they virtually all do this and have been doing it for years. So, yeah, and we've stayed quiet. None of us have turned out, virtually never stand up and say to the policymakers or to the public that actually the policies the government's developing are all based on nonsense. None of us do that. So we're all part of that. Because in a democracy, we take some responsibility for it. As scientists, if we don't speak out, then we are in agreement with what they're doing. Silence means consent. The old Thomas More's maxim. He still got his head chopped off by Henry VIII. And the last question is about geeks like me, so forget that one. Right. So I just wanted to find out what people's views were. It's slightly depressing. I was hoping for something a bit more upbeat. As I say, I corrupted last night, so I've got a slightly different covering slide to the title that I gave on the abstract. They call this one the ostrich of the phoenix. It's one I've used but a lot of the times. You're all familiar with these. The ostrich stuffing your head in the sand, what we're very good at doing as human beings, or the phoenix rising from the fossil fuel flames. And the other sort of subtitle is cognitive dissonance, which is a fancy academic term for hypocrisy, or creativity in a changing climate, doing something fundamentally different, actually doing the things that were paid for in university about being creative and imaginative, and then putting some grist and some quantification behind that. So that's what I'm going to sort of talk about, those two alternative views. My headline conclusion, because I'm always told it's very depressing what I have to say, is that I think the 2 degrees C characterisation of dangerous climate change, and it's, obviously that depends on what probabilities you're talking about, but at a moderately okay probability, 50-50-ish%, maybe slightly better, is still viable, I think that is still just about viable. I don't think we'll achieve it. That's the difference between that. I think we either choose not to achieve it. We collectively choose not to achieve it. It's just. But I think it will also have economic benefits. But economic comes from the original root of economics, which is oikonomia, which is the Greek term, which is, I don't speak Greek, so if anyone does, I apologize for my pronunciation. Oikonomia is stewardship of the household, the prudent use of resources. There is no reference in the original form of economics to this awful concept of money. Mammon and that only came later on. The modern version of it is crematistic, which is defined variously as the making of money, the acquisition of wealth. If we really think of economy as the economists originally thought of it, then I think that is just about viable with avoiding dangerous climate change. In fact, they go hand in hand in some respect. The modern form of it, the astrologists, numerologists, and other people that we call economists nowadays, I mean the sort of modern, neoclassical, marginal economist versions of them, at least when looking at issues like this, these are non-marginal problems. You wouldn't use Newton to understand subatomic particles, so why on earth do you use marginal economics to understand non-marginal problems? So I think that holds, and that one doesn't. And unfortunately it's the latter one that gives us the carbon trading and all the other stuff that we ramble on about. I think the only other significantly foreign word here is Friday. It wasn't last, it was Friday 2013. Now, in September, when the IPCC's science report came out, to me it's the most important of all the science, of all the IPCC reports. It's the one that's the most neutral as science can ever be, unlike the other ones, which I think are helpful but also slightly unhelpful reports. But it offered, as we'd expect, no solace to a fossil fuel hungry world. The science for policymakers hasn't changed since the first reports in 1990. You can pretty much say everything you wanted to the policymakers from the 1990 reports a quarter of a century ago. Some bits and pieces have changed, particularly from the mitigation agenda. In the adaptation agenda, I think it's different than the impact agenda. But in the mitigation agenda, we knew everything we needed to know in 1990. It's a mature science, so you get small adjustments and refinements. That's what science does. It doesn't generally take huge, great leaps, does from time to time, but this is standard science. There's nothing fancy about climate science. Difficult, but it's nothing out of what we've been doing for 150 years. So what has changed since the last IPCC report in 2007? We've put 200 billion tonnes of CO2 in the atmosphere. So that's one thing we've done during our period of concern on climate change, 200 billion tonnes. Our emissions now are almost 65%, as of now, are almost 65% higher than they were in 1990 when we first pretended to be concerned about climate change. Remember the Rio Earth Summit, all that other nonsense in 92, well, good stuff in 1992. Nothing came out of it. We just watched emissions go up year after year after year. Atmospheric levels, these are things you all know, 800,000 years, 3 times longer than human beings on the planet. Our levels now are higher than have been for 3 times longer, and possibly a lot more than that. I think that's the most conservative end of the spectrum. But for me, I focus on the mitigation side, so particularly looking at the emissions just go up every single year. The growth rate since 2000 in emissions is 3 times higher than it was during the 1990s. The growth rate is 3 times higher, and it's from a much larger number. And there's no sign of that growth rate coming down, despite all of our rhetoric. Yet we continually commit to these sorts of statements. Now, this is the Copenhagen Accord, but you could look at anything. You look at Cancun, Durban, Warsaw, no doubt you'll look at Paris this year. Something like this will come out again. To hold the increase in global temperature below 2 degrees, notice that it doesn't say a 50-50 chance of, it says below. So there's the language here. You can convert the language using the IPCC taxonomy or probabilities into actual probability numbers, probabilistic numbers, which allows you to do some work determining carbon budgets for their own statements, or our own statements as part of the democracy. Below 2 degrees, consistent with science, a radical idea, and far more radical on the basis of equity. So we should hold our paymasters to account. We sign up to that every year. We tell the poor people of the world every year, we're going to do that, and we're going to do it on the basis of equity, and then we come back home and we've finished our lives with them during the negotiations, and we carry on as we did before. Yet we sign up to this every single year. And look at all the internal government documents, they pretty much cover that as well. The CCC almost uses that sort of language, not quite. So to meet that objective, I say, my argument is, I'm trying to say that today, is you have to radically reduce energy demand in the short term, immediate term. Massively reduce our demand immediately. You need to do the other stuff as well, I'll come back to that, but that's my argument. But the argument you always get, and I hear this repeatedly, can't you just do it through low carbon energy supply? And that's someone who used to work on oil rigs and spent my time as an engineer, a lot of the time working on big bits of shiny kit. It's a shame we can't do it with those. I like those sorts of things, but they are not going to solve climate change. In fact, they're actually part of the problem, because we think they are going to solve climate change. You can't do it with energy supply. It's a prerequisite, but it will not be sufficient. In 2014 or 2015, should update the slides, it's about timing. Reduction targets for 2050, and I've been saying this for years, and a few other people have as well. We should never have spoken about 2050. Any scientist that ever referred to a 60% or 80% reduction by 2050 in the last 5 or 10 years should have their funding removed. So it has nothing to do with climate change, and it never has had anything to do with climate change. Not to do with 2 degrees C. It's just some random number for 2050. I mean, we can all just turn our lights on and do nothing for half an hour. It's before midnight in 2049 to 2050. And hey presto, we reach the 80% target. But it doesn't make a difference to climate change. It's the cumulative emissions that matter, the build-up of CO2. And that completely changes the framing of it politically and personally in terms of what it means for us. We don't like that, we don't like the science. That's why climate scientists are the worst climate skeptics, because we don't believe our own science, but it means we have to do something different. So we're much worse than the skeptics. But the next one, nations, what's also worrying about that is there is insufficient carbon space for gas as transition fuel. So I've done quite a lot of work on shale gas. You cannot fit shale gas into any reasonable budget for the UK. So however clean it might be, you cannot use shale gas, even with carbon capture and storage. Even with carbon capture and storage, for numerical geeks amongst you, it's still about 80 grams of carbon dioxide per kilowatt hour, still about 10 to 15 times higher than renewables or nuclear. And you can't fit that in the budget to any reasonable usage of gas with CCS. So you can't use that. It says that there. So the implications of all this are quite severe for how we have to think about climate change, particularly in the wealthy parts of the world. Just think about this graphically. You've all favour these numbers, so I can tell you roughly what they are. There are billions of tonnes at the side here, and dates at the bottom. Quite a lot of time I give talks to people who are not very good with numbers, so it's just lots of carbon up here, and for the future out here. This is 1980, 1990 here, when we had the first IPCC report, came out in 1990, and the panel was set up in 1988. These are emissions just going up here. And this is where our concerns start to step in, the Earth Summit. So as you know, that line's going to hold constant now and start to come down, isn't it? That's what, of course, we've done since Rio. And since, oh no, sorry, mistake. Royal Commission report, emissions keep going up. Copenhagen, emissions are going up again. 2009, the second Rio Earth Summit. Some of you remember that? Rio plus 20, people called it. Rio plus 20 years, I think it was Rio plus 20 billion tonnes. So emissions are now roughly 20 billion tonnes higher. This is a plot, this is an inverse plot of our concern about the world, about our own children. So that's our concern going up there. Despite the economic downturn, slowdown, I think would probably be a correct term, it only just dipped globally very briefly, but slowdown. Emissions have continued to rise. In fact, in 2010, it's probably kicked back into before that, emissions rose by 5%. 5% from a very large number. And since then, we've had 2 to 3% per annum rise since 2000, which I say is 2 to 3 times higher, almost 3 times higher than we saw in the previous, the last decade of the last century, 1990. So what are the future emissions? Well, energy systems, I work on energy, and most of my talk here is focused on energy. That's only part of the story, but it's a very big part of it. Energy systems have very long lock-ins. When you build a system for energy, whatever it might look like, whether it's a building, part of the infrastructure, it locks you into the way we do things for a long time. Power stations, you're typically talking about 25 to 50 years, 50 for coal and nuclear, 25 for gas and turbines, wind turbines. Large-scale infrastructures, buildings are going to be here probably be here for 100 years. The house I live in was built in 1860. The building I work in was built in the 1960s. Lots of our infrastructure has been there for much longer. So we think about the sewage networks, the electrical cables, they're there for decades and decades. Aircraft and ships, the Boeing 747 was first designed in 1964, first sold in 1969. It's still flying today, and unless you're a plane geek, you wouldn't spot the difference between a 1969 Boeing 747 and one that flies now. Now the Airbus A380, if it follows the same route, will still be flying in 2080. So that's the sort of lock-ins you get. Imagine the Airbus A380, it will be in the air in 2080 if it follows the same sort of path line as has happened with the 747s. So we lock things in for decades and decades. Same for ships as well. And that ship's typically 20 to 30 years old before we sell them to a poor African country. This is what we do with planes. And when they're about 27 years on average, then we flog them to African countries and claim our fleets nice and efficient over here. So if we extrapolate out, the reality always hurts, and what we always do, but it keeps our pensions going and keeps us on. Extrapolation at 3.5% per annum, which will, well, it should be a bit lower than that now, really, because it has dropped a bit. It was 3.5% CO2 at the time. And then dropping it out as we go forward. I think at the moment there's no sign that emissions will start to drop unless we find it really hard to get fossil fuels. But we're doing everything we can. I mean, the BP and Shell are trying to get underneath the Arctic. One of them's claimed it's not going to be quite so engaged now. They're trying to get tar. I mean, if you go to tar sands, you'll do anything to get the oil out of the ground. It's got nothing to do with economics. It's much more to do with the lock-in to a particular way of doing something. Now, tar sands makes coal look clean, and yet we're still doing that. So everything we're doing is to use as much fossil fuels as we possibly can. So if it does something like this, things are going to be pretty dire. But is that realistic to suggest that? Well, I think of the UK, one of the leading nations rhetorically on climate change. And when I say rhetorically, I don't mean that in a negative sense, a pejorative sense. Rhetorically, you have to go through the rhetoric before you ever get reality, before you get change. So the rhetoric's important. 25 years of rhetoric, you might argue, is a bit too much. So what's the UK, a leading nation in climate change, doing to help with getting our emissions down? Well, tax breaks for shale gas. Shale gas is 75% carbon, as is all gas, so when you burn it, you get lots of CO2. Chancellor's proposed 30 new gas-fired power stations with no CCS attached anyway. If CCS worked at scale, we don't know. We had the highest level ever investment in North soil last year. The year before, last year was the second highest, I think. We've reopened 3 small Scottish coal mines. We're expanding aviation and ports. The emission standards on cars have been significantly watered down thanks to Mercedes and BMW and Week's finest MEPs. And we're supporting Arctic exploration for hydrocarbons. This is the leading country on climate change. We opened a consulate in Alberta. What's next to Alberta? The tar sands. So the British government claims to be interested in climate change, and yet we're trying to sell our oil expertise so we can destroy as much of Canada as we possibly can to get the dirtiest fuel out of the ground. Now this is the leading nation. So what are the others doing? Imagine, so all I'm saying is that there's no reason that curve won't go like that, if not even go up faster, if the poor parts of the world start to develop like we've tried to, well, industrialise, I wouldn't say it's develop. So globally we're set to some very large amount of CO2, 250,000 gigatons up to 5,000 gigatons, something like that over the century, if it follows that sort of line, which is somewhere around a 4 to 6 degrees C temperature rise. Unfortunately, I think that's what the curve out. Yes, I did. Those that are aware of the IPCC scenarios, not the X-rays, the RCPs, representative concentration pathways, if you plotted that on there, 8.5 is lower than that. 8.5, which is the highest scenario you can imagine, which is very similar to everyone knows the old X-rays, is very similar to the old A1FI. It goes like that. It's below that curve. So the highest scenario that we're prepared to contemplate as scientists is lower than business as usual. Scenarios are supposed to capture a plausible range. They should be going well above what we've had business as usual. We also have a scenario 2.6, which is actually way below. In fact, actually peaks emissions well before now. So the RCP 2.6 requires you to have a time machine to make it work. But the other end of the spectrum, again, you can look at business as usual, which I think is really quite disturbing. And we've done this repeatedly as scientists for 20 years and they've played a problem, or potential problem. So if you play out those cumulative budgets, they look at something like 4 to 6 degrees C over the century. Now, there's a lot of uncertainty in this, and scientists are always very open about that, and have been since the beginning, I think. So, all the caveats need to be put in there that this is a very complex issue, and there are a lot of uncertainties associated with these temperatures, but that's broadly what comes out from the budgets in the latest IPCC report. But for 2 degrees C, that's all you've got to meet there. In fact, the sense that this was from the first report and the third report, but the synthesis report has updated the budgets, and they're basically giving you some very simple numbers. 1,000 gigatons is a 50-50 chance of 2 degrees C. So 1,000, we're saying we're aiming for 5,000. So we've got 1,000. Now, the work I'm doing at the moment, which I hope to update, is looking at cement emissions. We've pretty much ignored cement emissions, another convenient thing. A large portion of global emissions are from cement. A lot of it's from the energy side, which is factored into this. A lot of it's also, 60% of cement emissions are from the process side. And the assumptions in virtually all the scenarios I can find is that cement emissions do not go up anymore from where we are today. And yet cement is required to build all the new power stations, the wind turbines, the train lines, the new buildings are required to make it an energy efficient, low carbon society. And also, if you look at where the emissions are, it's from China. And why is China doing it? Because it's industrialising very rapidly. If India does that, other countries like do that, which in fact cement is almost a prerequisite of industrialisation, which some people would argue is a prerequisite of development, then there'll be lots of cement used in those parts of the world. No scenarios factor that in, because it makes the situation even more difficult, so we mustn't have the truth get in the way of a good story. But even if you ignore cement emissions, we were going to currently use up the total budget for 2 degrees C by 2030. That's the outside budget. If you use the lower end of the budget for 2 degrees C, we're going to run out of all of it by 2022. So the current rates we're going, we're going to have no hope of 2 degrees C. This is globally, remember. I'll come back to that in a minute. So recent evidence tends to support, recent history supports the IEA view, the International Energy Agency, who have not really ever been a radical left-wing think tank. They generally have been the sort of mouthpiece of the energy industry, but they are saying some very interesting and carefully worded things now, right across the board. So it's really worth looking at their analysis on all sorts of subjects. CO2 trend perfectly in line with 6 degrees C temperature rise, which will be devastating consequences for the planet. Now, whether it's 4, whether it's 6, what we're saying is very large temperature rises occurring very rapidly, which is more important, I suppose, which will have devastating consequences for the planet. I don't think even the skeptics would disagree with that. So what about 2 degrees C, which I think we can still get to? That's 46. If we think of 2 degrees C, it looks something like that. That's actually taken, I think, 1,300 gigaton budget rather than 1,000 gigaton that's in the synthesis report. But it doesn't matter too much. So that's what we'd have to do for 2 degrees C. There's an enormous gap between the two. And the worrying thing about this is the bit I do a lot of work on, and so I start working on energy, is that you can't do that with low carbon supply. You can't make the changes quick enough. You cannot build the things quick enough. You have to do something with our demand for energy, and that is very, very unpopular amongst all of us, all of our colleagues, all the policymakers. So basically the whole world, they're all the high emitting parts of the world, which is a very small proportion. None of us like this at all. That's why we don't really like the science. Tell us things we don't want to hear. So is it reasonable to assume you cannot make these sorts of changes quickly enough? And you get the Linuses of this world, or the Monbios, or the Lovebox, then you can do it all with nuclear power. That's a bit unfair on Monbiot, he's much more refined. But Linus isn't it, for the ignorant view of it. So nuclear power, a good example of it. I'm agnostic about nuclear power. I'm brought up next to one, my dad works as a fitter in a nuclear power station and died as a consequence. But I remain agnostic about whether nuclear power is good or bad from other points of view. But from a climate perspective, it's very low carbon. And that, at the moment, that's what I'm concerned with here. Its emissions are 5-15 grams per kilowatt hour, which is roughly the same as nuclear, as the renewable range. So it's way lower than CCS, way lower than anything else that's out there other than the renewables. So much lower than gas or CCS, for instance. From a global perspective, that's the final energy consumption that we use, just terawatt hours, lots of energy. That's how much we actually consume. It's not primary energy. It's not taking the account of the loss in the power stations. That's what we actually use to do the things we like to do in our lives. That's lots of energy. Electricity consumption is 20,000 terawatts. Now that's terawatt hours. That's pretty typical for most industrialised countries. It varies a bit. 20% is very common. So the UK is 20%, much of Europe is 20%, Sweden's 35%, and France is higher as well. But most industrialised parts of the world, 80% of the energy we consume is not electricity. Yet we always think about wind turbines, nuclear power. We always talk about electricity and energy as if they're the same thing. Both begin in E, both end in Y, but they're quite different. Nuclear power provides 11.5% of the world's electricity. So that means nuclear power provides 2.5% of global energy demand. Now, if you're going to go low carbon, you have to put a lot more things in the grid. So electricity looks like, the penetration of electricity looks like it has to go up very significantly. Maybe 60-80% of energy has to come from electricity. Because what else is there outside of that? Probably biomass, if you can make it grow it sustainably, and possibly hydrogen, which often is produced from electricity anyway, or from thermal decomposition. But anyway. So 2.5% of global energy demand is what nuclear provides today. There are 435 nuclear power stations that provide that energy. And so when you get the Monbiot's or the Linuses or others saying nuclear power is really the solution here, you have to say, well, how long will it take to build them? How many we're building today? Well, we're building 70 at the moment. Put it on there. I thought I'd put it on there. We're building 70 at the moment. So to provide 25% of the global energy demand, which would not be unreasonable in the sort of scenarios people talk about, if nuclear was provided as a low carbon source, provided 25% of the energy we need, you'd need about 4,000 new nuclear power stations in about 30 years, and we're building 70. So just, people have to go and do some contextual analysis around the assumptions that they make. These sort of things are embedded in all sorts of IMs, other things. They just assume at a point that things suddenly shoot up and, hey presto, we've got all of these new technologies. It takes a long time to build nuclear power stations and a long time to put all the other systems around it as well. That assumes you've got enough uranium-235 as well, or you transfer to thorium or something. So I think it's fair to say that that's correct. So we have to reduce demand. The low carbon supply is a prerequisite. You have to have it. So we need to build that stuff like it's no tomorrow, and I'll come back to that briefly later on. But remember, this is a global analysis, and we were signed up on the basis of equity. So we've signed up to do something whereby the poorer parts of the world get longer to make the transition across. And yet that's not actually in all the policies we develop for our own countries. We assume they're not going to do that. But our rhetoric says, yes, they're going to give them some space to develop and industrialise and improve their welfare, which I think we'd all think is not an unreasonable thing. So this is a much more demanding situation for us. So often you get, when I do these numerous scenarios, millions of scenarios out for all sorts of people on what the future might look like from an energy perspective. And you often get told, oh, you're not putting enough pressure on the poorer parts of the world, which I think is unfair from the sort of analysis that we've done. We're assuming in our work, these are very rough figures that capture a lot of the other work we're doing as well, but that the poorer parts of the world could peak by 2025. That's enormously challenging. That's all of the other parts of the world, but I think it's viable, just about viable. And China, as Peter said before, China dominates that, but actually India will start to dominate that or start to become very significant. But I still think collectively we could probably get a peak in 2025 if we were really serious about these issues. And that has to be a higher number now. If they could then start by 2030 to reduce their emissions at 10% per annum, which is 3 times faster than Stern says is possible with a growing economy, but I'm not taking too much. I like Stern for lots of other reasons about his view on discount rates, but in terms of things like this, I think the views of economists are almost irrelevant. And we don't know how fast we can reduce emissions instead of a growing economy if we think a growing economy is good. But the economists tell us that the rate we need now for this is 3 times faster than that it's possible for a growing economy. So that is hugely challenging. But then you sort of say, well, okay, let's imagine they achieve all of that, and we can work out the budget for those parts of the world. What's left for the rest of us? What's left for the wealthy parts of the world that's caused the problem, knowingly caused the problem for 25 years? We'd have to have at least 10% per annum reduction starting in 2011. So as we're updating this now, looking at some of the later numbers, which make it much higher than that. We think those numbers are going to be considerably higher. So starting immediately to give us a 50-50 chance of avoiding dangerous climate change that we sign up to as a democracy every single year. And probably as many of us as scientists who actually work in that sort of terrain. And that's a 40% reduction by 2018. So imagine your own life and say you want a 40% reduction in your energy consumption by 2018, which would go roughly with a 40% reduction in our energy, in our emissions, because in that time frame you're not going to change the supply system very much. 70% reduction by 2024, and this is why I've written to the PM and others about this. And before we had the EU policy on 40% reduction by 2030, which again has very little to do with, well, nothing to do with 2 degrees C. You basically need to be 90+% reduction in our emissions from the wealthy parts of the world by about 2030 to give us a 50-50-ish chance at 2 degrees C. And that's with very demanding constraints on the poor parts of the world. So it's not unreasonable for people to say that the chances at 2 degrees C are very slim. I think this is still viable, and I'm going to come to that. These are radical emission reductions, way beyond anything that's countenanced now. Any of the standard reports that come out there, they've got the great and good names on it somewhere, will not cover any of this stuff at all. It'll be glossed over with lots of eloquence and nice words and photographs. But we don't like the numbers, and that includes the Research Council. They do not like the idea of thinking of this as the challenge. They much prefer the 80% reduction by 2050. So why is this so different from what else you hear? Well, firstly, the probability of exceeding 2 degrees C, the UK probabilities, and the CCC, the Committee on Climate Change, are quite explicit about this. UK policy is premised on, it was an old style budget, so we can let them off for that, but 63% chance of exceeding 2 degrees C. So we say we're going to stay below. That sounds like you're going to make maybe a 10% chance of exceeding, a 90% chance of staying below. Remember, this is something that's dangerous. Imagine crossing the road, and are there any busy roads next to, well, if there was a busy road next to, get to the busy road and close your eyes half the time you cross the road and see how often you do it, how often you're successful. Now, that's dangerous. But this is dangerous, apparently, according to our definitions, which definitions are made by civil society, not by scientists. So we're taking here a 60 to 80% risk of doing something that is dangerous for the whole planet. But it does give you a much bigger carbon budget, which is why we do it, because it allows the policymakers to muck around with far more carbon. So basically say we don't have to do the things now, we can rely on technology in the future to solve the problem for us. And we all like that. It also depends on very inequitable apportionment of the global budget. So it basically says, let the UK have lots and lots more of that budget, and we've had everything else in the rest of the world, so let's break the budget as well now. So we just carry on with that colonial view, which I think is inappropriate. And we as scientists, again, stay quiet about that. It's not just the UK, it's other parts of the world as well. It has very Machiavellian peaks, so you could peak in the past, or you peak pretty much now, or you peak in the next 2 or 3 years. They're hidden in it somewhere in all of analysis, but again, scientists, we quietly support that. And the emission rate, in other words, once the emissions have gone up, and they reach a peak and it comes down, that's dictated in every single IAM by astrologists, or otherwise known as economists. So every single IAM has people coming, I should be a bit more careful, right? It's economists, market, neoclassical, marginal economists, I include the Chicago and Austrian School of Thought in economics and that as well. It's that group, looking at something which is non-marginal, looking at things that are step changes. It's inappropriate, their theoretical framework. Fine for looking at small changes, but not for the sort of things we're looking at. Yet we take notice of them. You know, the news like every night as well, I don't know why. So it goes up and it comes down at a rate, and that rate coming down is always 3 to 4%, with the odd blip up to 4.5 maybe. And that is dictated by them. And of course that changes the shape of the rest of the curve, because if God's spoken, of course economists are God, if they've spoken, then you are locked into that descent curve, which means your budget is locked to that part. So therefore you have to tweak everything else, like the peaks, or like you have to have geoengineering. So you'll do everything you can, but question the fact that economists might be wrong. And geoengineering is pretty much ubiquitous. Virtually every single scenario has that. Does anyone know about the paper that came out, Christopher McGlade and Paul Eakins, the one recently saying that 75% of all the hydrocarbons remain unburned? Yeah. Do you know how much geoengineering was in that? 350 billion tonnes. So 10 times current emissions, 10 total years of current global emissions are assumed in that, and you have to dig into the spreadsheet. I mean, Christoph's great. You speak to him, they'll send you all the data, all the spreadsheets. It has very little emissions for cement. Deforestation emissions are in there appropriately, in my view, and a massive amount of geoengineering to make even the fact that 75% of the current fossil fuel reserves can't be burned. This is in every single paper out there. It's hidden somewhere that Dr. Strangelove works. Now, it may well be that Dr. Strangelove will work. You know, the geoengineering, if you've ever seen the Peter Sellers film, if you haven't, it's well worth watching. Peter Sellers film, Dr. Strangelove, it's about geoengineering. Now, I think we should research it, but I don't think we should assume it works. That is incredibly dangerous, and yet every single low-carbon scenario that we come across assumes it works. The only two we can find that don't assume it works, peak emissions in the past. So I think it's universal. So 2 degrees C looks too difficult. You tell the policymakers now go, oh, I can't do that, it's a bit challenging. So what about a 4 degrees C future? And I'm sort of leaving from 2 to 3 to 4, because actually the probabilities of 2 are probably slim anyway, so we're on the moderate probabilities of 3 heading towards 4. So I'm just trying to simplify it. That gives you a larger carbon budget, which means your rates of mitigation are more in line with what's politically palatable. But what are the impacts? Now, it's not an area I work on at all. I've just taken some stuff that came from the Hadley Centre and the Foreign Commonwealth Office a few years ago, and maybe it needs updating, I'm sure it does. But they broadly were saying on the hottest days during the heat waves, if you had a 4 degrees C global average, this is stuff that probably most of you are quite familiar with, you get an 8 degrees C rise around Europe. Now, what I find interesting about that, I'm a PI on a project looking at electricity network and resilience to changing climate. Most of the cables, in Exeter as well, most cities and towns, the cables come underground. The cables coming underground to keep our fridges working and our water pumps working and so forth, those cables are cooled by soil moisture. During times of prolonged heat waves, the soil moisture evaporates. That means the cables can't carry as much power. So the cables can't carry the power to the fridges during a prolonged heat wave. When we've got the air conditioning units on that require more power, fridges are working really hard, and we have showering and bathing more in cold water, trying to keep ourselves cool, particularly at night. So you get massive loads when they come to the cables, which no longer can cool, so the cables start to collapse. Now that's fine. So imagine that in London. You've got 3 days of food in London, but your fridges aren't working, so it's much less than 3 days of food, because you're now in a heat wave and your food's perishing much quicker. So you think, we'll bring the food in from the ports, but that's fine. But the tarmac, of course, was never designed for 8 degrees on top of the current heat waves. So the tarmac's melting, so the trucks can't bring it in. The cables are buckling for the trains. So the infrastructure we've built cannot allow us to bring the food into London. Now, some of us might argue that's not a bad thing. But you start to see the infrastructure, when we think we're resilient to these things, our basic Victorian infrastructure was not designed for these sorts of changes, let alone load on top of that in a population of 60 plus million people. So even here it's quite bad. In China, look at the buildings they're putting up there, they've got virtually no thermal mass, very hard to keep cool, 6 degrees, and across the water in the States, it's talking about 10 to 12 degrees. So this is, say, happily sent to work, just trying to give some sort of potted account. 4 degrees C has major repercussions in terms of extreme events. And the norms are important, and I'll come back to actually from food. Sea level rise, well, you're probably all as familiar with me about that. Up to metre sea level rise by the end of the century, I think that's still not a reasonable number to use. And it would go on. 4 degrees C means we're going to lock in a lot more going forward. So I understand at 4 degrees C, you pretty much wipe out the ice in Greenland eventually. Is that correct? 4 degrees C? That's 7 metres. So that, just think of, there's some humility we should apply there, that we're going to fundamentally change the shape of land mass around the planet. Now, it won't change in the period of time that we put the emissions out, but we would have knowingly done that in about 50 to 100 years. We would have knowingly changed significantly the shape of the land masses around the planet from what we're doing now. Now, okay, it will take some time to come about, but geologically it'll take no time to come about. I just think there's something in that. I mean, there's some humility that's required, but we think we can do that, and that's appropriate to do that. And also they suggested that the crops would, 40% reduction in staple crops in the poorer parts of the world, in the southern hemisphere, pretty much. At the same time, the population is going up. And I think a lot of that is actually not due to changes in rainfall. I think the temperatures themselves become a real problem. So the actual heat itself is problematic for the growing of the crops. It's not my area again, but that's my understanding. At 2 degrees C, a lot more of the changes in water, access to water. So there's a widespread view. I mentioned if you take a similar view and meet this, I've been trying to poll scientists anecdotally for years on this, that it's beyond what we could call compatible with organised global community. We'll start to fight when we start to see these sorts of changes occurring around the planet. We won't politely negotiate with our neighbours to divvy out scarce resources. And we saw that in Darfur when the pasture lands changed there because of changes in rainfall. People didn't get around a table and negotiate. People picked up a Kalashnikov and shot each other. And we generally, particularly blokes, are very good at doing that. So we don't tend to respond in a reasonable fashion to stresses. And we're not doing that now. Look here, we've got 2 Poles and a Romanian arrived in Britain. And we've got the whole political party, the whole of Europe now, changing their policies because we've had a little bit of migration. So as soon as some problems come along, migration during an economic collapse, which has got nothing to do with them anyway, and yet we will blame someone else for it. So we all do that, even us in just nice, supposedly sophisticated society. So it's beyond adaptation, I think, it's reasonable to say. It's devastating to most ecosystems, and it's unlikely to be stable. And there are people here who know a lot more about that than me, but as I understand it, the temperature goes up, the probabilities of it remaining stable, and if you're not hitting some non-linearity in the system, are higher. And at 4 degrees C, I think that you're probably going to get much nearer kicking some of those off, and how they play out, well, the other people can comment on that. But I think it's reasonable to say, if you look at that, then we should avoid 4 degrees C at all costs. And the interesting thing about all, it doesn't matter if you've got neoclassical economists with you, because it beats the discount rate. So they can apply any discount rate they want, but all will always beat it. So you have to do everything you can, regardless of cost, to avoid 4 degrees C. And you can have these, if anyone wants these slides, see some people scribbling down, you can have the slide and some stuff that goes behind it if you want to. So is 2 degrees C still a viable goal? My hypothesis is yes, but I'm finding it quite hard to get any funding to do this sort of research. The research capitals aren't too chuffed with the sorts of things I say. Firstly, from an equity perspective, it comes to be an equity issue. It's not from an equity perspective. If you look at it, actually, who are the emitters? They're a relatively small group of people. That makes it much easier to develop policies in some respects, because you haven't got to make policies for 7 billion people, you have to make policies for about 1 billion people. So we're probably less than that. So we know who they are, we'll come back to that in a second. Second is there's a huge amount you can do with technology, but most of it's on the demand side. So we can do a tremendous amount of things with the small bits of kit that we use every day, laptops, cars, toasters, those sorts of things. Those have a very quick cycle through, so we can do a lot with those, and I'll come back to that. And the last one is on growth, this mythical thing that we have to follow. It's interesting now, the Hadley Centre have, I won't say who it is, but they have a senior scientist whose title now is Head of Integration and Growth. Now, why on earth has the place that deals with climate and weather got someone whose title is Head of Integration and Growth? Why is it the research councils, all of them now, say that our research you have to say something about what you can do and benefit economic growth? And why have we stayed quiet about it? We're no longer arm's length from government, the research councils and universities. We're their handmaiden. So I'll come back to that. One of the reasons you'll get funded when you say things like that. Pareto, I'm trying to get some other money to do some detailed research into this, but it does appear that these numbers are broadly hold. Pareto, Vilfredo Pareto, Italian economist, political economist, the nice ones, back in the mid-1800s. Rule of thumb in engineering, you'll probably come across this in almost all fields. 80% of something relates to 20% of those involved. It doesn't always hold, but it's not a bad rule of thumb. 80% of emissions come from 20% of the population. Actually, that seems to hold not unreasonably. But the question is then, if you go back into that and say, does that hold within that group? And it doesn't seem unreasonable if you run it 3 times. It still sort of seems to, anecdotally from tests I've done, and we're interested to do this, run it 3 times. But that tells you something which might be interesting. 50% of the emissions come from 1% of the population. Actually, that's what is interesting, is that I've been using that number for years, and it's quite similar to the wealth one that's recently come out. Now, if you think wealth and emissions relate, they do to some extent. They're not one-to-one correlations by any means, but they're quite a lot of correlations. So it seems to fit with some of the data that's out there, but it's very hard to collect. What do you do about savings? What do you do about work flights and work trips that the wealthy of us like to have that actually are partly holiday as well? So it's tricky to do this. I think more realistically, that sort of number gives us some sort of guide. 40 to 60% of emissions come from 1 to 5% of the population. But they're still quite helpful to know that there's only a small proportion of us that really are the main problems in the shorter term. And who are they? Well, every climate scientist that doesn't spend the rest of their life on a jet somewhere. Every academic pretty much in the OECD. I must be doing this at a charity recently. I just changed that usually where I'm giving a talk. NGO employees in charities. Anyone who takes an annual flight or 2, that will pretty much lock you into the top few percent, because you also know if you fly, then your emissions, then your income is much higher than the average, even in our own country, and therefore your emissions are much likely to be higher. So 2 degrees C's mitigation is a short-term challenge. It's not a long-term challenge, despite the fact we keep trying to say it is. It's really now in 2025. If we're serious about 2 degrees C, and if we're not, then we should be open about that, to let people who, let the poor parts of the world know that we're going to make no attempt at all for 2 degrees C, and then they need to be thinking about adapting for 34, whatever it might be. It's a consumption problem, not a population problem. The population is regularly brought up. It doesn't matter what the median or the mode is going to earn in China. It's irrelevant. Because by the time they're anywhere near what the current mean is, we'll have had to shift to a low-carbon energy supply system. So in the time frame that we have, even with 100% trickle-down economics, which has never occurred in the history of humankind, assuming it did, that even if that worked in China, then the Chinese poor people can never be the consumers of the things that are going to emit lots and lots of CO2. Because by that time, we'll have had to convert to a low-carbon energy system. So it's a population, a consumption problem by people like us, not by the poor trying to become wealthy. A few of them will. There's 300 million people in China that consume like us in the OECD. So I'm not saying it's not other parts of the world. It's the wealthy right around the world. They're the ones that matter for 2 degrees C. For 3 and 4 degrees C, the budgets are bigger, the time frames are different, and then the poor start to matter. For sustainability, the poor matter. Poor people don't eat roughly the same as well. Probably a poor person probably eats half as what I eat. But it's only differential 2. In terms of energy, I probably consume 10 to 100 times more energy than a poor person. So it's different from sustainability to climate change. So where does that leave us? Just think of the example of flying. If we're to avoid dangerous climate change, every tonne of CO2 from our flying added to our already high emissions, because everyone who flies regularly, most academics, you've never seen them get off a bus. They're always in a taxi, because they have really important lives. Along with the policymakers and the business leaders and all the others. So our emissions are high in every other facet of our lives, including our large houses that we leave heated at home when we go abroad. So we add all that together. Every tonne that we consume is a tonne that a poor person somewhere can't consume, because you've got a budget to play on. So a tonne of a poor community they can't emit, which means basically that their welfare is held back, because their welfare will be improved by access to fossil fuels to give them access to more energy. Because we know at the lower end that actually access to energy improves their welfare very significantly, very high correlation. Not with us. Using more energy for our lives doesn't make us have a higher, improved welfare. This statement's been shown repeatedly, right around the globe, over and over again. So the difficult choices, this is an example of flying, but do we fly to another conference, family visit, sun-kissed holiday, or in my case, I have lots of friends who are rock climbing for a weekend in Spain because the weather forecast is bad in the Peak District. And that's appalling in my view, but do we do those sorts of things? And if we do, then what we have to say is we have to consciously think that through. We are stopping them having access to the basic needs that they require if we're going to stay within the current budget. These are very, very uncomfortable questions we have to ask ourselves with everything that we do. Or we just do the cognitive dissonance thing, hypocrisy, stuck your head in the sand and be the ostrich, which is what we've been practicing for 25 years. And if we both admit, then we have to say that we don't really care about climate change impacts on the poor, which we don't, of course. We pretend we do, we do a bit of research on it, but by and large we think damn about the poor. Just make TV programs that we can turn over for. I mean, we think about what do we give at the moment. We've ring-fenced the money for international development, but it's still very, very small. Incredibly wealthy countries ring-fence a fraction of a percent, and then think they're doing something significant. So I think we have to be a bit more reflective in what we're actually doing as a community and as individuals. Now, there's an upbeat part here as well that goes with this. Technology. An A-rated fridge uses 85% less energy than an A-rated fridge, an A++ fridge rather. So why, if we have to have a fridge, why on earth would we ever buy an A-rated fridge? And that's no consumer's fault, because an A-rated fridge sounds quite good. Why is it we actually have them? Why is it not simply a standard in there that says to the manufacturer, you've got to have an A++ fridge, and next year we're going to increase the standard by 10%, next year after that another 10%. Why don't you do that? The companies will moan and squeal like they always do, then before you know it, they'll be very happy to deliver the technology. So why is it we have this ridiculous choice of rubbish fridge if we want to? And they're a very large consumer of our emissions in the households. I'll come back to this in a minute. Cars, I think there's another slide with that. Cars are a really good example. I'll come back to that in a second, actually. I think it's there. And most appliances have very short replacement cycles, unlike power stations. So most of the stuff we have replaces really quickly. So you can very quickly change our technologies, our demand for energy, provided you deal with the rebound effect, because we normally just spend it on another jet ski holiday somewhere. So, whatever we do with the holiday, we do with the money. So cars are interesting. EU emissions in the US, 12-15% of our emissions come from cars. This is from private use of cars. This sector is often said to be intractable. You often hear that, or cars are really difficult to deal with. Rubbish. There are 270, in fact more than that now, 270 model variants of diesel and petrol cars. These aren't electric, they're not hybrid. These are standard diesel and petrol that emit less than 100 grams of carbon dioxide per kilowatt hour, per kilometre. There's another set, I think it's 180 of them, that do 95 or less. In every category, so every single category car is set for sports and SUV, which you don't really need, do you? I mean, only performance out those cars. You can bloke have small ego. So they aren't that essential really in our world. 62% of all vehicle kilometres, are travelled by cars that are 8 years and younger. That's say for the UK and the US. For the UK and the EU, I think it's different for the US. So, and actually most of those kilometres are travelled by the cars that are 3 years old and younger. So you could get a 50% reduction in 10 years, and a 60% if you had a scrappage scheme. This is just with normal retirement rates. I hope there's another, So this intractable sector, think about this. This is an intractable sector, apparently, so-called, with no additional capital cost, so no increase in capital cost anywhere at all, a reduced operating cost, because you haven't got to buy as much fuel. These cars are just are actually cheaper to make than a lot of the average cars that we buy. They're not expensive to make these cars. Identical infrastructure, same petrol stations, you need a few of them. But no change to the infrastructure or the habits of how we do these things. No employment change, because actually the companies that make the efficient cars also make the rubbish cars that we normally buy. So it's just you just change the production line, so it takes about 2 years at most to do that. So no employment changes. Same companies. So all of this is an intractable sector. You can do with all of that, no cost, no infrastructure changes, no behavioural changes, other than you have to ignore Jeremy Clarkson. And you would have in 10 years a 50 to 60% reduction in emissions. And we can't be asked to do something as simple as that. And the refrigeration was the same. 70% of UK domestic electricity from fridges. We placed them out with A+ or A+++, and there's a fourth plus, I think, now if you dig around. And you can have savings similar. Very large savings in 10 years, just by replacement cycles of existing equipment with a standard that's put in place. It requires your politicians to be vertebrate rather. So they've got to start to stand up to the companies, which they won't do at the moment. Because at the moment there's no cost of these things. And the final one, growth. Committee on Climate Change, Stern, and lots and lots. I have a lot of time for both those organisations. I mean, they've added real clarity to the debate. They've been very brave in lots of respects. Nevertheless, they both toe a very political line rather than an independent line. 4% mitigation is about as high as you can possibly get with economic growth. They both say this. But the economist's economy is stalled. Why on earth do we take any notice of them anymore? Their own economy is stalled. Alan Greenspan at a certain says that he was, what's the word he said? Wasn't shocked. He was shocked that he found a fundamental flaw in his model. Markets do not self-regulate. You can wander around outside and find anyone's pet that knows that markets don't self-regulate. So everyone in the world, anything with a brain in the world, except for Greenspan, it would appear, who was the head of the Federal Reserve in the US, knows that markets don't self-regulate. And that was a shock to his model. So why on earth would we listen to these people night after night on news, like pontificating about the economy they couldn't predict before? We'd never do that. We don't listen to people on cold fusion telling us about it anymore, do we? They're going to do a bit of work, it's shown not to be the case. We don't listen to them again. But we drag them out every single night on every single subject. Universities are dominated by them. The news is dominated by them. Why are we doing that now? This is a real chance to think differently about these issues. And actually, a lot of economists are thinking differently outside of that small group of them. You know, university economists have a much wider range of expertise than these neoclassical market ones. So self-regulated markets have failed. With bumps, actually changed. It's 375 billion. We put 375 billion pounds. That's a third of this country's GDP. We put that into quantitative easing, which effectively is real money, even though people say it's not real money. It brings about change. In this case, it made the bankers much richer. It took money from the public purse and handed it to the private purse, and they took it abroad. Well, what a big surprise that was. It was supposed to be a stimulus package. 350 billion. For 200 billion, you could have retrofitted every single house in the UK that will be here in 2050. That's 17 million houses. 26 million houses in the UK. 17 million of them will still be here probably in 2050. You could have retrofitted every one of those. That would have pretty much eliminated fuel poverty, made them much more resilient to a changing climate, and significantly reduced our emissions. We could have done that for 200 billion, and George could have still squandered the other 150 billion somewhere else if he wanted to. So these are the sorts of monies that we should be asking for, not the paltry sums that in the Green Investment Bank of £3.5 billion. So we have an unprecedented opportunity to think differently. Ignore the economists and the astrologists. Start to figure out this situation in a much more, in a more philosophical and a more engineering and a more quantitative basis. So all of the other disciplines need to be thinking about this and taking much less notice of this very narrow discipline that's been dominating this issue for a long time. And also remember that growth subsumes the things that really matter to us. No one gives a damn about growth. What you care about is your welfare, the well-being of your children, health, life expectancy, employment, income, equity, literacy rates, low crime. These are the things that you care about. This is the heterogeneous world in which we live, the world that is complicated, that's measured in lots and lots of metrics, if it's ever measured at all. Most of you probably don't measure your love for your children, and yet economists, of course, will do it for you. And yet we take all of that, we take all of the rich texture of life, and we convert it into the homogeneous, into the pound or the euro or the dollar. And then that lot go out there and they'll get the value, and they've already done this. I think Ian Bateman, maybe it was wrong, it wasn't Ian, but someone else did a CBA analysis, looking at the value of bees in the UK. It came out to be 4 times the value of the chair of the Royal Bank of Scotland, the one that was sacked. So the value of bees in the UK is 4 times what we paid the head of the Royal Bank of Scotland. These value systems are meaningless, but once you put a price on it, you can substitute car parks for trees, or car parks for the love of your children. Once economists have done that, that means you can substitute. And we need to move away from that. That dominates our policy discourse at the moment. It dominates how we think about our own universities. It has no meaningful value, and yet we have quietly, very educated people like us have sat by and quietly allowed this pervasive, pernicious discipline to dominate everything that we do. And it has some real virtues in economics as well. But once it becomes like it is now, it's incredibly dangerous. So last 2 or 3 slides. I think we need a radical plan for 2 degrees C. I said I think it's very viable. I think we can still do it. I think it's incredibly unlikely we will, but we will choose not to. It's a choice that we will actively make. We need to radically reduce our energy demand. We can all do that now. Most people in the UK emit far, far less than us because they just simply don't consume as much energy. And they live okay lives. So we could dramatically cut back on our emissions, and we could be vociferous about it with our colleagues, our friends, our families, our politicians. We could do that. We won't, but we could do that. And the Marshall-style plan, probably not many of you remember the Marshall-style, the Marshall plans, but anyway, the big reconstruction programme after the Second World War, we need that sort of style of planning, really, which is not going to be driven by markets. Markets have niche roles in that, but it's much more from a planning perspective. For low carbon energy supply, we definitely need to build these things like there's no tomorrow. And I include in that CCS for the poor parts of the world. They need CCS because their budgets are bigger and they can use CCS. So all these technologies need to be seriously considered. And in that, I would say geoengineering as well, but it shouldn't be part of the portfolio of mitigation measures. It should be something we look at separately. That may be an insurance policy that may pay out, but may not. So ultimately, we must escape the shackles of the 20th century mindset, and I think that completely dominates how we think about the world at the moment. If we're ever to resolve 21st century problems, 21st century problems are systemic problems. They're not ones you can solve through this simple, simplistic reductionist view that we've taken. This demands leadership, courage, innovative thinking, engaged teams, and very difficult choices at every single level, from the individual to the institution to the government. This is a quote from Bob Dylan I always use. I've never paid him any royalties for it, but I really like this. I think it captures, maybe it just captures my view of the world. In fact, one of my colleagues had this from my 50th. Had a breadboard made for me with this printed on the bottom of the breadboard. I've seen it so often. At every level, the greatest obstacle to transforming the world is that we lack the clarity and the imagination to conceive that it could be different. And that's our job in universities, clarity and imagination. And I would say on top of that, it's to provide some substance to that clarity and imagination. But that is our job. And at the moment, we are not fulfilling what the public are paying us to do. If you're interested in the sort of things that I ramble on about, I have a Twitter account, Kevin Climate, and a website where I write quite a lot of things, one sort or another. So thank you very much.